So today we are going to do mins and maxes in 3 dimensions. So for a function f of x comma y. It's called the second partials test. It uses the second derivatives, or second partial derivatives of a function. So in order to get ready to do this, we are going to do 2 problems right here. I want you to find and justify, identify and justify any relative minimum and maximum, the x coordinates for those, using the second derivative test. So I've got 2 problems here, this one and this one. If you don't remember the second derivative test, then you can listen to me do the work for the first one, and then you could try the second one. If you remember it and you're like, oh yeah, I find the critical values, and then I find the second derivative, and I plug in, I look at concave up or down, and that tells me min or max, boom, you can go ahead and do that. So right now, hit pause, and I will do the first one, and then I will open up, or then I'll have you pause again and do the second one. So hit pause. The statement that you should have for number 1 at the end of all your work is we get a min at x equals plus or minus 2 because f prime is 0 and f double prime is positive. I always draw concave up to make sure that I'm saying the right word here. We get a min. We get a max at x equals 0 because f prime is 0 and f double prime is negative. If you want to see why that's true, or if you want to see that full process worked out, I'll walk through it right now. If not, hopefully I'll post a timestamp and you can go and you can check your work for number 2. So let's see, what do we do to get to this statement? So the first thing we do is we find f prime. F prime is 4x cubed minus 16x. Then I set that equal to 0. Remember, I'm looking for critical values. That's when the derivative is 0 or undefined. So I can factor a 4x out, and then I open my parentheses, and I get an x squared minus 4. And then that x squared minus 4, I get 4x, and then x plus 2, x minus 2, right? And what values make this equal to 0? Well, I get CVs, at x equals 0, comma, plus or minus 2. So at this point, I've shown that f prime is 0 for those 3. Now what I need to do is find the second derivative. So I'm going to come over here and take the next derivative of that. F double prime is equal to 4 times 3 is 12, x squared, and then minus 16. So now what we do is we find f prime of negative 2. Well, that is 12 times negative 2 squared minus 16. And look, this is 12 times 4. It's way bigger than 16. So this is positive. The better way to do it would probably be to say that that is greater than 0, but it's fine to just say it's positive. And then f prime, that's f double prime, I'm sorry. F double prime of a positive 2 is the same thing. It's positive, right? And then that is what I've done there is verified this right here. F double prime is positive, right? And then the next thing I do is do the same thing for f double prime of 0. Well, that's 12 times 0 squared minus 16. And that's just negative 16, which is negative, right? So I know that f prime of all these are 0, and then 2 of them have a positive second derivative, 2 of them have a negative second derivative, or sorry, the other one has a negative second derivative. I always draw concave up for this positive second derivative. I draw concave down so I don't make a mistake. This is clearly a max. This is clearly a min. And then the next thing I would do would be just to write these 2 statements. So since I've already done that, let's see, can I get it? Copy, paste, boom. After all this work, I would just make these 2 statements. So hopefully you remember the second derivative test. And now, if you have not already done it on this one here, you can do it here. I'm not going to walk through the whole thing, but I will show the work. So hit pause, and the answer is going to pop up in just a moment. So this is the work that you should have. The first derivative is this. Set it equal to 0. I get 0 and plus or minus 1. Then I go and I find the second derivative. I get this thing. I plug in the 0 and the plus or minus 1 to those to the second derivative. I get negative for the 0, which I draw concave down, get a max. And then I get positive for the plus or minus 1, draw concave up, it's a min. And then I make these two statements right here. So hopefully you remember the second derivative test, because now we are going to bump it up to a much more intense version to be able to do it in 3D. The first step of the second partials test is to do the same thing that we did up here. I take the first derivative and I set it equal to 0, right? So when I have a three-dimensional function, a function of two inputs, I have two different derivatives, two partial derivatives. So critical points are when f sub x of a comma b equals f sub y of a comma b equal to 0. So I need both partials, the partial x and the partial y, to be equal to 0. What that does is it makes it instantaneously flat in the x direction and instantaneously flat in the y direction. So if we were to do a tangent plane, it would be parallel to the xy plane. And those become our candidates for things to be minimum or maximums in 3 dimensions. So we're going to do 3 examples like this. First one, f of x comma y equals 6 minus 3x squared minus y squared. Now this is one that you might even be able to visualize in your head what kind of shape it is in 3 dimensions. It's 6, it's got a minus x squared parabola and a minus y squared parabola that kind of go down at different rates. This is a paraboloid that hits at 6, right? Goes like this, and then like this, and then like that, and it's like steeper in the x direction, right? So it would not be circular, that would be an ellipse right there, but that's what this thing looks like, and it hits at 6, right? So we know this thing has a max at that spot just because of intuitively what we know about this shape. But let's find the critical point. So what do? I find f sub x. When I partial x this thing, the 6 goes away, the 3x squared turns to a negative 6x, and then this y squared, there's no x term there, so it gets treated as a constant, so I just get that y squared. Then I take f sub y, right, and the 6 goes away, negative 3x squared, there's no y, so that goes away because the x gets treated as a constant, and then this gives me minus 2y. So I want f sub x to equal f sub y to equal 0, right? So I sort of build that. No, I shouldn't really write it like that. I should write it as I want, just use the eraser. I want f sub x to be 0, and I want f sub y to be 0, right? So what does that turn into? That turns into negative 6x equals 0, and negative 2y equals 0. And it should be pretty obvious that that is x equals 0 and y equals 0. So what is my a comma b point? It's 0 comma 0. And that matches up with our intuition. Notice it's instantaneously flat when x and y are 0 for this multivariable function. So let's do one that takes a little bit more work. Same idea. This one's also a paraboloid, but it's moved around a little bit. Example 2. Let's do f of x comma y equals 6x minus 4y minus x squared minus 2y squared. We want to find, there's one critical point for this thing. Why don't you pause and see if you can find it? Okay, it is at 3 comma negative 1 if I've done my work correctly, and I'll show you where that comes from. Partial x is equal to 6 minus this guy derives away, and then this guy right here gives me minus 2x, and then this guy derives away. Partial y is equal to, 4, and then this guy goes, I should have said there's no y here, so it goes away, derives to 0, this derives to 0, and then this guy gives me minus 4y. it's a negative 4 right here. Boom. And then minus 4y. So I say 0 equals 6 minus 2x. 0 equals negative 4 minus 4y. If I solve for this, I get x equals 3. And if I solve for this guy, I get y equals negative 1. And that's where that comes from. Hopefully you're picking this up. Let's do one more. And this one has, I think, 5 critical points. So let's take example 3. F of x comma y equals, all right, we got 2x to the 4th plus y to the 4th minus 2x squared minus 2y squared plus 3. All right, so let's do our partial derivatives. F sub x is equal to, all right, I got 8x cubed. This guy goes away, minus 4x, and that's it, right? Is that correct? 8x cubed minus 4x. Good. Let's do partial y. That is equal to 4y cubed. That's the derivative of this, because this one has no y in it. And then minus, I should make that look like a cubed. Cubed minus 4y. Is that correct? 4y cubed minus 4y. So now what I'm going to do is, just like with this one up here, you know, I factored this thing to set it equal to 0. I'm going to do the same thing down below. And if I do that, notice there's a 4 factor for both of them. And then I can take an x out, and I get 2x squared minus 1. And then for this one, I get 4y times y squared minus 1. I think it's pretty obvious that this one goes to 4y, y minus 1, y plus 1. This one's a little bit more work. It is difference of two squares, so I'm going to write it as 4x. And then what I'm going to do is just square root this term, right? And that gives me root 2 x minus 1, and then root 2 y minus 1. Or sorry, x minus 1. X. Okay, so now, here's how this works. We pair things. So, what I mean by that, look, x equals 0. Oh, there's far more than 5, I think. X equals 0 will make the top 0, right? Notice y equals 0 and y equals 1 makes the bottom 0. And so does y equal negative 1. So 0 with 0 works. That would be this term and that term. Next, 0 with 1 works. Next, 0 with negative 1 works. What I did there was I paired this guy with this to make them both 0, and then this term to make them both 0, and then this term to make them both 0. Next thing that I'm going to do is pair this guy with this and this and this. And then the next thing that I'm going to do is pair the third piece with these 3, right? So I think that makes 9 different ways. Is that right? I'm going to write them out because I'm about to run out of time. So these are our points. You can see over here I took this guy right here. I set it equal to 0, divided by the root 2, and then I rationalized the root 2 over 2. If you wrote 1 over root 2, that's fine. But then I paired that with this and this and this. Then I took, you know, if actually there's a mistake there. This should be a plus. I'm sorry if that bothered you earlier. But then I get the negative version of that same thing because it was difference of 2 squares, right? So I get these 9 points. Now you may say, man, there's got to be an easier way to do this because I rewrote everything. And there is. You could just write 0, comma, 0, 0, and then 0 plus or minus 1. That's these two. And then notice it's plus or minus root 2 over 2, comma 0. And then I can get all 4 of these guys here by writing plus or minus root 2 over 2, comma, plus or minus 1, because pairing those all together would give me those 4. Hopefully you're with me here, and we will do some more in the next video.